Alright, well, first off, happy Friday to everybody. Sorry that I'm not here on a business trip with my wife, but I will be back Monday, and there's plenty for you to do, so no worries. So first things first, you should have picked up the paper at the very front of the door, or the sub has it for you. Most importantly, this is a grade. Alright, so we all know what to do with that. So when you are finished, you will turn it in, and you will turn it into the box. The sub will not pick this up. This is responsible for you, so you are responsible for getting it into the box and making sure that you have your name on it. Alright, fantastic. So what we're going to progress with is we're going to move on to the first question. So looking at the first question, so first things first, we will read the question just like we always do. So number one says, Arthur is going to trick or treating for Halloween, so he puts new batteries in his flashlight before leaving the house until the batteries die. It draws 0.500 amps of current from a 1.5 volt C-size battery. How much resistance does the bulb's flashlight create? Alright, so reading it is fantastic, but what we really want to do is after we read it, we want to identify what they give us. So we're starting on our guesswork. So G, under G, alright, we read all the way through there. The first thing that it tells us is that it draws 0.500 amps. So what we know amps is your amounts of current, but remember that we denote current with a capital I. So in this case, I is 0.500 amps. Fantastic. All right. Right after that, it says a 1.5 volt C-size battery. So 1.5 volts we know is our voltage. So we're going to go ahead and put V. V is our voltage, and it in this case is 1.5 volts. Fantastic. We keep going. There's all of our givens. We head to our unknown. Our unknown in this case is going to be the resistance. So we put R question mark, which makes life really easy. So looking at the top of the page, I've already given you the right equation, and the equation you're going to use is going to be Ohm's law. So in this case, they tell us that Ohm's law is I is equal to V over R, and so we have that. But as we have all recognized already, the problem is that we need to solve for R. And solving for R in this case is going to be slightly difficult because it's going to be a two-step process. So we've circled R on the bottom, and the first thing we've got to do is ask ourselves, is R on the bottom of the fraction? And the answer, of course, is yes. So the way we're going to fix that is that we first have to multiply by R. And if you do it to one side, you've got to do it to the other. So now you're left with this equation of R times I is equal to V. And again, we circle R because we're searching for R. And we ask ourselves the first question again, and the first question is R on top of the fraction? And yes, now, R is on top of the fraction, but the second question is R by itself? And the answer to that one is no. So what we have to do is we have to get R by itself, and the way that we do that is we get rid of I, and since it's multiplying by I, we're going to divide by I, and if you do it to one side, you've got to do it to the other. So I's gone, and what we're left with is R is equal to V over I, which is fantastic. So we have R by itself. What we're going to end up doing is we're going to substitute, so we move on to our first S, which is to substitute. So in this case, R is equal to V, and V is 1.5, so we have 1.5 volts, and I is 0.500 amps, so 0.500 amps. We plug this into our handy-dandy calculator, and our handy-dandy calculator comes out to tell us that it is 3, and we have to know what the unit is for resistance, and the unit for resistance is ohms. So if you remember that it is an upside down horseshoe. Now our only problem is that's right, but we need to make sure that it's in proper sig figs, and we got to make sure that we use the proper unit on the end of it. So going back and looking at our two givens, the current had 3 sig figs and the voltage had 2 sig figs. So between 3 and 2, 2 is the lesser of those, and so we have to have 2 sig figs in our answer, so we say 3.0, and then the unit is still ohms. So your answer on that guy would be 3.0 ohms. And that would be it. So on the next slide, there's actually a much neater version of this instead of me drawing it, and you can see that guy. So here's the same thing. It's just much neater, and it's not me penciling in everything. And so if the sub would like to, they can stop here, and that way you can catch up a little bit. But that's stepping all the way through the guesswork on problem number 1. So we've read number 1, we've solved number 1, but then there seems to be a follow-up question that goes with number 1. So we read that section. It says, if Arthur changed out the bulb for a new one that has twice the resistance, then what would be the new current? Fantastic. So we've read it, and first things we do right after we read it is we're going to start our guesswork. So we have G. Alright, well, our givens, we have the resistance that we know from last problem. The resistance was 3.0 ohms. And it's really important that you write 3.0 and not 3, right? The 3.0 tells us that we have 2 sig figs, so it's really important that we do that. Now, they told us that it's going to be twice the amount, so we take that, multiply by 2, and it comes out to be 6.0 ohms. So we know our new resistance. The resistance is going to be 6.0 ohms. We also know we're going to be using the same battery. So the battery is still 1.5 volts. So resistance of 6.0 ohms, voltage of 1.5 volts, and we're going into our unknowns. So in this case, they want to know what's our new current. And that's fantastic because our new current is I. So we're looking for I. RVI, obviously, which equation are we going to end up using? Well, we're going to end up using Ohm's law. So I, the current, is equal to the voltage over the resistance. And we go ahead and circle for what we want to solve for. We want to solve for I, and we ask ourselves 2 questions. Well, is it on the bottom of the fraction? It's not. It's on the top of the fraction, so we're good there. And is it by itself? And it is by itself, so we're also good there. So what we know is we have the proper equation. So we go ahead and start with our first S, and our first S is going to be to substitute in. So current is equal to the voltage, which in this case is 1.5. So we have 1.5 volts. Divided by our resistance, and our resistance in this case is the 6.0 ohms, so we do 6.0 ohms on the bottom. Fantastic. We don't have to change anything else, so we go ahead and solve, and we plug it into our handy-dandy calculator, making sure that we use parentheses, and I comes out to be 0.25, and the unit for current is amps, so we put an A on the end of it. Making sure we use proper sig figs. R had 2 sig figs, our resistance had 2 sig figs, the voltage also had 2 sig figs, so that means that our answer has to have 2 sig figs, and it definitely does. So writing it a little clearer, a little neater this time, the current would come out to be 0.25 amps. So what I need you to do is, I'm going to do the same thing like I did last time. The next slide over is going to be a little clearer, and it's going to be written in computer font instead of my awful handwriting, so you can catch up on that. What I would like for you to do is, this is going to be due by the end of the day, so you have the rest of the class period to finish it. And there's not too much, it's just guesswork, and it's all using the same problem. If you have any questions, the sub does have a key. They are not going to give it to you, and they're not going to give you answers. But if you have questions, then you can definitely come up and ask them. Besides that, have a good weekend. Please don't hurt anybody, including yourselves, and come back and see me Monday. As promised, here it is. And so we won't worry about that. See you later.